We are starting with functions, transformation of functions specifically. And before we start the question, let me write down what are the different transformations that we deal with. So when we talk about transformation, there are three transformations that we deal with. In red, I'm writing reflection. With blue color, I'm writing translation. I'll just change the color. And a third color for stretch. So let me just change the color. That is in blue color. And the third one is stretch. So that is in green color. Now, when we talk about reflection, there could be two possible reflection. It could be reflection in x-axis, reflection in y-axis. Now, there are two things to consider. What happens to the coordinates, as well as how will the original equation be changed. So let's say in every case, the original equation is y is equals to fx. It could be linear, quadratic, cubic, modulus, trig, anything. When we reflect it in the x-axis, y is equals to negative of fx. And when we reflect in y-axis, this is y is equals to f of negative x. Now, just focus over here. Reflection in x-axis, there is a minus on the outside. So let me write the word outside. When it's reflection in y-axis, there is a minus on the inside. Now, what happens is that when we reflect something in the x-axis, so something from here goes up till here. And when we reflect in y-axis, something from here goes this way. So now when we reflect in x-axis, only y coordinate changes sign. When we reflect in y-axis, only x coordinate changes sign. For example, let me just shift these two a little bit downstairs. If I have a point A, comma B, it will be changed to A, comma negative B. If I have a point A, comma B, it will be changed to negative A, comma B. Perfect. Now let's focus on translation. Translation could be along x-axis, or you can say it's parallel to x-axis, or it could be along y-axis. It could be parallel to y-axis. Now we have a translation vector hk. So this h is along x-axis. It could be right, it could be left, it could be positive, it could be negative. And over here, k, it's along y-axis, up is positive, down is negative. Now, when we talk about how to write it, that is something separate. As such, the value of h and k, if it's positive, just like O-level maths, just like IGCSE, it's along the x-axis, that is positive. Along the positive x-axis, the number positive means move right. Now, what happens is that if we write it, f bracket, and this is along x-axis, f bracket x plus h. The value of h itself is positive, but there is a positive sign before that. That means move h units left. And if it is f bracket x minus h, h itself is positive. There is a negative sign before that. It means move h units to the right. Now, when you will define these transformation, it is necessary that you should also write the vector. So that vector will be in the column vector form. And when I'll do questions, I'll write it over there. They won't simply be satisfied by you saying it moves this many units to the right. That should be written, but vectors definitely should be written. I think it would be better if you just focus right now rather than copying. So that just focus single-handedly. If we write fx plus k, and this k is on the outside. So that means the graph moves k units up. If it says fx minus k, the graph, which is a collection of points, the graph moves k units down. Now let's talk about stretch. When we talk about stretch, it could be along and it could be parallel. Both words can be used. It could be along, it could be parallel to x-axis, and it could be along, it could be parallel to y-axis. When the stretch is parallel to x-axis, now I think among all these 6 transformations, this one is the most trickiest one. Let me first explain along or parallel to y-axis. Y is equals to AFX. There is A on the outside. When A is on the outside, what happens? If there is a point, for example, A, let me write instead of AX comma Y, because I'm already using the symbol A. So what happens is that X remains as it is. The Y coordinate is multiplied by A. And by the way, I'll write scale factor as SF. So the scale factor is A. The Y coordinate is multiplied by A. Now, when we talk about stretch parallel to x-axis, this is of the format y is equals to f of ax. Now, this A is on the inside. And what happens is that a point such as x comma y will become actually x over A comma y. In other words, let me write this thing as 1 over A into x comma y. Instead of multiplying by A, it is multiplying by 1 over A. The scale factor still is A. The scale factor is in the denominator. Now, when I'll do these questions, you will have a much, much better idea of what's actually going on. So now these are the 6 transformations. Let's have a look again, and then we'll directly go to the questions. The first thing, that is reflection in x-axis. Y is equals to negative fx. Negative is on the outside. If it's reflection in y-axis, it's f of negative x. It's this negative is on the inside. That is what is happening. That is what is happening. What happens to the coordinates? Because we have to look from the perspective of coordinates. AB becomes A negative B. Over here, reflection in y-axis, the x coordinate changes sign, y coordinate remains the same. When we talk about translation, we have to write the translation vector. We have to write it in words. Either it could be a horizontal translation or a vertical translation. Of course, if it's a combination of both, you have to define each one separately. So if it is f bracket x plus h, we move h units to the left. Plus means left, negative means right. But with respect to y-axis, plus means up and negative means down. The same kind of scenario is over here with the x-axis also. It's kind of the opposite. So if it's stretch along x-axis, what happens? Y is equals to A of fx. The x coordinate is multiplied by 1 over A. Let's use the term multiplication as we use in geometric progression. The common ratio could be 2. The common ratio could be half. Multiplication by 2, multiplication by half. Let's not use division so that there is no confusion. We have one single word to deal with, multiplication. If it's parallel to x-axis, the x coordinate is multiplied by 1 over A. Scale factor is still A. If it's parallel to y-axis, the y coordinate is multiplied by A. The scale factor is still A. All good? All clear? Now let's look at the first question. Just read it. Don't try it. I'll do every single question myself. The graph of y is equals to fx is transformed to the graph of y is equals to 1 plus half x. Describe fully the 2 single transformations which have been combined to give the resulting transformation. Now, the very first thing is Over here, they are not specific about the order, and that also says in the mark scheme. You can do one transformation first, then the next one, and in reality, even if you do it, the answer will not change. It's not just that the examiner is being pragmatic, okay, since he has written the question, so let's go with the flow. No, it doesn't make a difference. Yes, there could be some transformation, which we will see, so in which the order will definitely make a difference, but over here, as such, there is no difference. So the rule is that we start from inside out. So we start from inside and then we move out. That means we should start with the function f and then move on. I think that is the best way. Now, first of all, f of half x. Now, think very comfortably. The x coordinate is multiplied by half. It's half x. And over here, there it is like this. So it is of the format, and f of half x means that it's a stretch parallel to x-axis. And since it says half x, that means the scale factor, this value 1/2 into x. So now the scale factor is this thing. So scale factor is 2. Let me just double check. The scale factor is 2. X direction, you don't need to write this, or y axis invariant, just ignore that. So now over here, this is the scale factor. That means the x coordinate is multiplying with 1/2. That is the first thing. What is the next thing? The next thing is this addition of 1 on the outside. So if it's addition of 1 on the outside, it is a translation. And this is the graph moves 1 unit up. Yes, the graph does move 1 unit up, but what is the translation vector? So the translation vector TV, that is 0, 1. Now let's look at the mark scheme. Translation or shift, you can use both words. Let's just stick with transformation. A translation, 1 unit in the y direction, translation shift 0, 1, except transformations in either order, allow 0, 1 for the vector. What it means is that if someone has written a coordinate instead of a column vector, mark also that is correct. But officially, it should be a column vector. All good? That is the first question. Let's move on. Let's read this question. It says in each of the parts A, B, and C, we will focus on one part at a time. They are not interrelated. There are 3 separate parts. In each of the parts A, B, and C, the graph shown with solid lines has equation y is equals to fx. That is the original. The graph shown with broken lines is a transformation of y is equals to fx. Now, if I focus on this first one, what do I observe? Is that this is right away a reflection in y-axis. And also double check. This point is 2, 1. And whenever you have to double check, do not check with a point in which x and y coordinate are the same, because you won't be able to distinguish what actually happened. So choose this thing, 2, 1. This becomes negative 2, 1. Now look at this point. This is 1, 2. This becomes negative 1, 2. I mean, it's very, very obvious. We're just checking it. So therefore, this is reflection. How? What exactly is it asking? Is it asking us to describe it? Or is it asking us to write the equation? It's asking us to write the equation, right? So let me write for myself. It is reflection in y-axis. This definitely you should write. That means the new equation should be y is equals to f of negative x on the inside. So therefore, state in terms of f the equation of the graph with broken lines, that is y is equals to f of negative x. The second one. Now it says the same thing, state in terms of x the equation of the graph. Now let me focus on 3 points. The first point is this red one, this one becoming this. So let me write over here. This is 1, 2 becoming 1, 4. So this is 1, and this is 4. The next one is this point. Let me focus on this. The blue one, 2, 1 becomes 2, 2. I think 2 points are more than enough. 2, 1 becoming 2, 2. Now, what do we observe? We observe that the x coordinate is unchanged in both the points, and definitely it will be the same in the third one. What is happening is that 2 is becoming 4, 1 is becoming 2. The y coordinate is multiplied by 2. Therefore, 2 is the scale factor. When 2 is the scale factor, that means we should write this as 2 times f of x. Actually, have they written? Yeah, x. So y is equals to 2 times f of x. This is a stretch parallel to y-axis. The y coordinate is multiplied by the third one. What is happening over here? The graph shape is unchanged. It's neither compressed nor stretched. The shape is exactly the same. It's just being shifted, translated. And now there are two translations. Not only is it moving horizontally, it's also moving vertically. How many units are we moving horizontally? That's 1, 2, 3, 4. 4 units to the left. I'm looking at this perspective. So either you can do it by counting, like initially I'm doing, or you can also use calculation. Let me first do it by counting. So 1, 2, 3, 4. 4 units to the left. 1, 2, 3 units down. So basically, by looking at it visually, it's 4 left, 3 down. That means -4, -3. That is the translation vector. That's one approach. The other approach is, let me mark this point, which is 2, 1. Let me mark the corresponding point, which is -2, -2. So 2, 1, something was added, which is hk, and it's giving us -2, -2. So therefore added, it's always added. Whatever plus minus will be there, that will be in hk. So this is object, this is translation vector, this is image. So hk equals to -2, -2, which is -4, -2, -1, which is -3, which is exactly over here. So this is based upon basic, very, very basic calculation. That was based upon just looking at it visually. It's for 2 marks. I think it's 2 marks because 1 mark for this, 1 mark for this. It's not because of any steps. It's because of accuracy. If you write -4, you will get 1 mark. If you write negative something else, you will lose the mark. If you write 4 but with a positive, you will lose the mark. So getting that negative right, getting that 4 right, that is a must in this case. Y is equals to f of -x, y is equals to 2 of fx, y is equals to, now the third part is left, my bad. This we have written, actually we have to write in terms of fx. We don't have to find the translation vector, we have to write it. Now when we write it, we will write fx equals to, actually y is equals to fx something. And let me write it like this. This is f bracket something plus minus something. What is happening is that even though it's a -3 in calculation, just like O-level maths, but you will write x plus 3 because plus 3 means move 3 units left. And then you are moving 4 units down. So you will write negative, that is the y, my bad, let me correct myself. So this is f bracket x plus 4, and this is -3. Okay, so 1 mark for each step. So that is this. Now, something to do with quadratics. Express x square plus 6x plus 5 in the form x plus a whole square plus b, where a and b are constant. So the first part is about completed square method. X square plus 6x plus bracket square minus bracket square plus 5. What goes inside the bracket? Half the coefficient of x, which is 3, which is 3. Rewrite the first 3 terms as a perfect square. This is -9 plus 5. This is x plus 3 whole square minus 4. That is what you get. Now, the second part, that is about transformation. The curve with equation y is equals to x square, the basic quadratic, is transformed to this equation. Describe fully the transformation involved. Now, the easiest way is that we have y is equals to x square. The coordinates of the turning point is 0, comma 0. We have y is equals to x plus 3 whole square minus 4. The coordinate of the turning point x minus h whole square plus k. Therefore, this is negative 3, negative 4. That is what is happening. The coefficient of x square is the same, so there is no stretch along the y-axis or along the x-axis, nothing like that. The only thing that is happening is translation. So this 0 is becoming negative 3. So 3 units lift. And this thing 0, the y coordinate 0 is becoming negative 4. It's 4 units down. So it's very similar to the previous question, except the previous question last part was not based upon quadratic, but we were dealing with the vertex. So basically, it's like a modulus graph, because in P1 there was no modulus. Now we have studied modulus, so this is kind of a modulus graph for a particular domain. We don't have to worry about that. But we were dealing with the vertex. Over here, we are dealing with the turning point. Turning point, another name is vertex. So therefore, are they asking us what is happening? Yes, they're asking us what is happening. They're not asking us express y in terms of fx. Describe fully the transformation involved. So we will say, we will take the graph of y is equals to x square. We will first shift or translate, whichever word you are comfortable with. 3 units lift, and then translate or shift 4 units down. And if they were to ask for the equation, let's say if the original equation was y is equals to fx, we will write y is equals to f bracket something and then something on the outside. 3 units left, I'll write x plus 3. 4 units down, I'll write minus 4. I think it's very similar to the previous one. Yeah, that was 4 on the inside and negative 3 on the outside. So that is the answer. This is the completed square form. This is translation of shift, the column vector. I wrote it down. I should write a column vector according to what the examiner has asked for. So over here, this thing, and definitely the column vector, negative 3, negative. That is a master. So now next one. This one, I would pause the recording and I would ask you people to solve it. Now let's ask this question. The question is in the diagram, the graph of y is equal to fx, solid line graph. Solid line is not shown with broken line transformation. This type of transformation that are combined with the resulting. This line, that's one thing. Now, first of all, I'll focus on this point. I'll focus on this. So now this is 0, 2, becoming something, and then it's becoming 4, 7. Let me focus on the other point, which is half, 1, becoming something, 2, and then which is 4.5, 3. Now this observation. Is becoming 4. So we cannot say it's multiplied by 4. 4 into 0 is 0. It's an addition of 4. Half is becoming 4.5. That means that means that is one thing that I observed. Second thing that I observed is that 2 is becoming 6, 1 is becoming 3. So therefore, now this is a state in which the y coordinate
me describe it. I make that mistake. It's along the x-axis. This is translation 40. This is switch factor key in y direction. Y. This is all we have. Now it says state in terms of y, and x. Y is equal to something, x something. So now, first of all, this is scale factor 3 times y-axis on the outside, and then it is moving 4 units to the right. So therefore, in this bracket, we will write x minus 4, that is 4 to the. So this is 3 x minus 4, that is the answer, and transformation can be given in the order. Now, another question. This is the first one is just like symbolic, the second one is spell. Let's start with the first one. The first one says the graph of y equals to fx is transformed to the graph of this. Now they have given us the equation. They are asking us what is happening. So let's work inside out. Inside, I'll write what has happened is that the graph translated, the graph is this is one unit to the right, or we say this have to give the column vector. So this is 1 comma 0, that is the column. What is the next step? The next step is this 2 on the outside. Now this is and this is factor is response. Let's double check. 1, which factor 2, scale factor or factor visibility is y direction. This also allow shift and allow by one in x direction or parallel to, parallel on, parallel in, parallel along, parallel again. So then using all these, I don't know what you call it in English, preposition or conjunction, whatever that is. Okay. So horizontally along x axis, translation by one to the right. Acha, translation by one to the right only scores 0 mark. You have to give, like, it's not about right or wrong, it's about parallel to exact. And the column vector should be given. H amplitude double. The y coordinate is the amplitude. Fifth, y factor 2 in y direction, parallel to on along again with y axis vertically or with x axis variation. That is the terminology of O-level math, which is transformation, don't use the variation. Fifth, y factor 2 upwards only scores 0 marks. So that means along x-axis, along y-axis, that should be mentioned. The factor should be mentioned. Column vectors, translation vectors should be specifically mentioned. Except SF as an abbreviation for scale factor. That they accept it. Note transformation can be in either order. Except an unsimplified version, which that's the next one. Now the next one. Now it says that the curve y is equal to sine 2x minus 5x is reflected in y itself. Which y a scale factor of 1. Now, as soon as I read this, let me write two things. First of all, y the next thing that I need is this. Direction factor is the same thing. Okay. Now the scale factor is one of the things that it has the opposite effect. Remember, y is equal to multiply by 1 over 8. It's reciprocal. That means if the scale factor what is a. So therefore, I should write wherever there is x, I should replace it with ax. Wherever there is x, I should write bx. Now, first of all, they're asking for reflection. So step one, reflection, red color. The first thing is that y is equal to of the whole thing. Sine x, not the whole thing. That is not reflection. That is reflection of x-axis. This reflection is y-axis. Sine of negative 2x minus 5 into negative. Wherever there is x, y replace it with negative, negative. Now the examiner accepts both of them. Either they have accepted the answer as sine of negative 2x, or you can use a little bit of trigonometry. One item is in the first quadrant, one is in the fourth quadrant. They are not exactly the same except for the plus minus sign. Positive in first and fourth quadrant. So if I apply this rule, so what I will write, I will write sine of negative 2x is negative sine and minus 5 and minus x becomes positive x answer of the first step, the first transformation. Now, step 2 is this thing that wherever there is coefficient of x, multiply that by 2. So we already have sine of 2x, we already have this thing. So this is y sine 2, and this is what goes inside the space, what goes inside x, this comes up. This comes. This is negative sine 6x plus 15x. That's the option that I took. And some people they wrote sine of negative 6x as it is. They did not simplify according to trigonometry, but still they have marked it. Because technically it was not a question of trigonometry, it's a question of function. So they are not interested in this one. Still, except the unsimplified version, V1 for each correct component, square brackets inside required component, either sign of this thing or this thing. Like if someone corrected one thing correct and the other thing wrong, then they will get it happen. This is also very common mistake, provided the concept is not clear, multiplying by one thing. If x axis, then it is a straight parallel to x axis, x direction. The rule is f of ax. That means the straight factor is 1 over. If it was f of 4 written like this, then scale factor 1. If it is f of 1 plus x, then scale factor is. Okay. Now again a question of quadratics. I just pause the recording. I would like to solve.
So now let's look at the solution of this question. That is fx and gx, two functions are there, and it's for all real values of x. By first expressing fx and gx in completed square form, express gx in the form f bracket x plus p plus q, where p and q are constants. And then we have to describe the transformation. Now, first of all, it's a question of completing square method. So let me simplify fx first. Fx equals to x squared minus 2x plus 5. The process of completing square says make sure the coefficient of x squared is 1. If it's not 1, take common, but it's already 1 over here. X squared minus 2x plus bracket square minus bracket square plus 5. What goes inside the bracket? Half the coefficient of x, which is negative 1, negative 1. Rewrite the first three terms as a perfect square, that is x minus 1 whole square, minus 1 plus 5, which is plus 4, that is fx. Similarly, let me simplify gx according to the completed square form, that is x squared plus 4x plus 13. that is x square plus 4x plus bracket square minus bracket square plus 13. What goes inside the bracket? Half the coefficient of x. Rewrite the first three terms as a perfect square. Simplify the rest. Negative 4 plus 13, it's positive 9. Now, the next thing, underneath both of them, write ax minus h whole square plus k, ax minus h whole square plus k. That is the gold standard. That is to get the vertex, the turning point, the stationary point. So over here, the stationary point in fx, that is negative, actually positive 1 comma 4. That's the turning point. And when we talk about gx, the turning point is negative 2 and 9. So this is 1, 4, negative 2, 9. Let me first double check. X minus 1 whole square plus 4. That is all good. The other one is x plus 2 whole square plus 9. That is all good. Now let's play around with the turning point. We are converting fx to gx. So now 1, 4 plus the translation vector hk is giving me negative 2 and 9. So therefore, hk is negative 2, negative 1, which is negative 3, and 9 minus 4 is 5. Now, this is the column vector which describes the transformation of fx to gx. Let me write it in words. We will say the graph is moved, translated, shifted, how many units to the left? 3 units left. And the graph is shifted 5 units up. Now we have to express gx in the form. So we will write gx equals to, because this is 3 units left, so we will write x plus 3, and this is f. And what is left? Fx plus p plus q. And what is q? That is 5. Let's double check. Fx plus 3 plus 5. As far as the explanation is concerned, that's already done. It's translated, shifted this many units to the left and this many units up. So this one is